This week, Paul and I discuss how application security solutions fit into the DevOps process. In the news, an ESLint package was caught stealing NPM credentials, a remote iOS bug can be used as a denial of service for Chinese users, and a discussion on how tickets make operation teams miserable. Stay tuned for all that and more on this episode of Application Security Weekly.
This is a Security Weekly production. Layered Insight is the industry's first embedded security approach for containers. Trusted by Global 1000 enterprises to secure their containerized applications, it's the only solution that requires no root privileges, has zero dependency on the underlying infrastructure, and is fully portable across any container environment. Unify DevOps and SecOps, enabling the rapid development of containerized applications without worrying about security. To learn more, please visit layeredinsight.com/ASW. Rapid7 powers the practice of SecOps. Using shared data, analytics, and automated workflows, SecOps unites IT, DevOps, and security teams to make security an outcome of innovation. Rapid7 combines technology, expertise, and advocacy to drive vulnerability management, application security, incident detection, and log management for more than 7,000 organizations worldwide. Power up your SecOps practice with a free trial at rapid7.com/securityweekly. Hard-coded credentials can be trouble, but not as much trouble as a vulnerable DevOps environment. If you want protection without the hassle of security slowing you down, CyberArk, the #1 provider in privilege access security, has the solution for you. With CyberArk Conjur, developers can easily secure secrets across any DevOps toolchain or platform, whether your application runs in the cloud or on premises. Eliminate the headaches of managing secrets and try Conjur open source for free with no strings attached. Visit conjur.org/ASW to get started today.
Welcome everyone to episode 24, our 25th episode of Application Security Weekly. I am, of course, your host, Keith Hoodlet, and I'm excited to be joined once again by my illustrious co-host, Paul Asadorian. How's it going, Paul?
Good. How are you, Keith? Excited for this episode, as always, here on Application Security Weekly to talk about all things application security.
Yeah, I mean, in this case, we are once again falling on the DevOps bandwagon, and that's right, folks, DevOps. It's not DevSecOps or SecDevOps or NoOps. It is DevOps. And so, Paul, I wanted to talk a little bit about, a follow-on to last week's episode where now that you've got visibility into your applications in terms of version control, what should you be doing to actually secure those applications as part of the DevOps process? And of course, we talk about in DevOps fast flow, rapid feedback, and of course, continuous learning. So a little bit of opportunity in here for a lot of different security solutions to fit the space. Paul, I don't know if you wanted to talk first, maybe a little bit about traditional security solutions like dynamic application or static analysis tools, and then maybe we can take it from there, because when people think application security, that's usually what they think of. So,
yeah,
any thoughts? Where do you want to start?
Yeah, I think just kind of in prep for the show, is kind of drawing out I guess it's 5. It could be more. There likely is areas where you're going to apply some kind of security solution to your process of developing software. And I think, let's see if we start as far, and this is leaving out some things, right? But if we start as far left as possible, I think you have, well, threat modeling, right? That might be a different discussion. I think right after that, you need some kind of source code analysis. I mean, maybe you don't need it. That's certainly debatable, but there needs to be some, or it could be beneficial to have some kind of solution that's analyzing the source code and looking for potential security vulnerabilities. Now, do we differentiate between security and other such bad things that might be in your code that you can avoid? Sure, because we could have that discussion. But that's kind of like, without talking about vendors, without even talking about static source code analysis, like as the code is being written, as it's being checked in, checking that code for some type of condition is certainly a major approach, right? I think following on to that, going with the check-in process, right? So if I put these in order, I think second for me is analyzing your source code repositories and check-ins for vulnerabilities and or licensing issues with open source software, which could even extend to other modules, right? That would be the second area. That's like a white source or a black duck or whatever, just to give a couple of examples there. I think the third part is maybe your DAST, right? Is some kind of dynamic testing process. That, you know, maybe that's, obviously we've talked about it in conjunction with some of your QA testing. I think that maybe fourth might be your container or operational security if you're using containers. Having some visibility into your orchestration and container from a security perspective is certainly, I think, the new way that you monitor your infrastructure, right? Because it's not really your infrastructure, it's kind of like part of your operations, right? And then the fifth area that I've got is some type of WAF or RASP or IAST or web protection or next, like whatever you want to call that, right? There's something inside the application or some kind of visibility into your application that could be monitoring for two different things, in my opinion, right? Like, one is monitoring for folks, evil bad actors that are going exploiting stuff and looking at actual attacks coming at your application. The second is looking at those and looking for vulnerabilities in real time, and hopefully tying those two together, perhaps. So I don't know. Those are the 5 areas that I came up with kind of off the top of my head right before we started the show. Oh, Keith, I think you're muted. Oh, you're still muted.
I am, in fact, muted.
There you go.
I would say one more that I would tack on, and a lot of people kind of poo-poo the idea, but training, I think, is also yet again one of those things that you need to include, probably as a 6th, right?
Yeah.
But to follow that order, Paul, I think that you hit the nail on the head now. One of the things that I like to differentiate, depending on what you're trying to do, is either is it compiled software or is it interpreted software? And by that, I mean, does it literally produce a binary, or do you have to run it through some sort of engine, whether that's, you know, Python or a web server or what have you, to actually then produce the features and functionality of the application? And so depending on what you're doing, some of those solutions will apply, some won't. So, for example, static code analysis, right? I was having an interesting discussion with a friend of mine named Aaron, who works at a large Fortune, I don't even know, but they're a large bank. I'll just say that. And we started discussing the difference between static code analysis and binary static analysis. Two very different things, but feel like they're the same, right? So, especially when it comes to static code analysis, you have 2 ways of doing that as well. You can do it pre-push to code or push to version control. So something that lives into IDE and starts to identify things before any sort of pushing of code takes place. And then you have post version control, which is now it's in the version control environment and can be scanned as a collective, right? So in some ways, I think that, especially the second point that you made, which I think was open source software, right? Libraries, yes, frameworks, etc., that might be considered static code analysis, maybe, right? Because
no, you're right.
It could be post, you know, like post push to version control, but it could also be pre, depending on the tool that you're using. So I would agree that for that space, in my opinion, anything that lives in the IDE is probably the best solution in my mind. Now, the reason that I say that is because it's universally applicable, right? It can apply to binary or interpreted software, so compiled or interpreted, and it's the fastest feedback mechanism in terms of literally it's in your IDE, right? You can't get any faster than that. The drawbacks, though, I think as a lot of people would say, you know, this is why all the other solutions exist, is that it has the potential for false positives. Right. Because it's interpreting what you're writing, it doesn't actually know what the truth is when you're running it. So I don't know, Paul, if you have any comments there, but
I do.
Yeah. Go ahead.
So my friend Dave, whom we're going to get on the show, I promise we're going to work on that. He's local here to Rhode Island, and has been doing software for a long time, and he's really, really good at thinking about the process and helped me understand some things about the process. And one of the aspects that he talked about when I asked him, hey, like, so how do you manage this process for some of your clients? And he started talking about like what breaks a build.
Yep.
And so like I took that back and I'm like, so we collectively, if you're producing software, have to decide what stops a build and what doesn't, and how those two things are handled, right? So if I'm in my IDE and it's picking up on a vulnerability, I could choose to ignore that. Maybe I fix it, maybe I don't. But what types of things will maybe not even let me go to build, right? So when I go check that in, if the system, and I don't know if this technology necessarily exists, right? But like, let's say my IDE has flagged 5 issues and I've chosen to ignore all of those and I've just kept coding because I have a deadline. Then I go check that in, and the check is, well, 3 of those 5 are critical. You can't even check that in, or you can't check it into this branch. Like, I've checked it in for another branch, so you can continue working. You got to fix those 3 issues. You get to decide what those issues are and define them, and define what actions are taken, whether it lets it go or not. And I think in all of these steps, right, your SAST, your DAST, maybe not so much your WAF, right, but your open source system, you know, maybe even your container, because there's a scanning component to containers, right, that it's not like DAST, it's kind of somewhere in between.
It's more like vuln management, I would say. It's more traditional vuln management.
Sure. In any of those points, they could identify a problem. You decide what kinds of problems stop a build, which ones don't, how those tickets are generated, if at all. Maybe if it's a lower level vulnerability, maybe you don't generate a ticket. Maybe you do. I don't. Maybe it's a different classification of tickets, right? You get to decide what that process is. And I think all of the tools we talked about are just that, right? They're tools to help you implement your process. And what I found running our own software project here is you can fall into this trap where you're letting the tool define your process, and that's bad.
Right.
Right.
Yes. I was actually just going to say, like, for me, I try to be not necessarily tool agnostic, but I want to be conscious of, first of all, what's the potential for false positives in the tools that I'm using? No matter what the tool is, static code analysis is going to produce more false positives than, say, binary static analysis, right? Than, say, a human. A human is probably going to produce the least amount of false positives. So to that end, for me, I kind of think along the same lines, right? It's not only the criticality of the vulnerability that matters, but the chance for false positives to take place. So if you think about it this way, I would rather not prevent someone from being able to push into version control, depending on, again, maybe the type of vulnerability matters for the type of thing I'm producing, right? So I might be project specific. This is a customer facing, highly utilized, revenue generating application. Breaking the build there is going to be something that I have to be really sensitive to, but I also want to be sensitive to the vulnerabilities because, if it's a critical vulnerability, it could cost us a lot of money as a company. Now, on the other side, if it's something that is in an embedded device that is, I don't know, outbound only, and it doesn't really have a whole lot of interactivity, and it doesn't really interface with a lot of people or a lot of business processes, maybe I can be less strict about that. But that's the other side of it too, is you have to start thinking about, depending on how you've architected your application or applications, whether or not it's worth applying more stringent rules to that application. So you also have to start considering those side of things as well. But yeah, I mean, it's a situation where you want to think about, okay, is it going to produce a lot of false positives or not? If it is, maybe I can let some of the high, mediums, lows slide past. Criticals I don't want to, or at least I require some sort of break glass and exception process there. But then you also have to think about, how many times do you want to have an exception process before you eventually say screw the exception process and just let it go. So then you run into broken Windows theory and all those other problems around how many times you let a bug through before you finally say, okay, we're not even doing security anymore. We're just letting anything into production. So for me, it's almost like, okay, IDE feedback best because it's fastest, but also doesn't want to break the build because potential false positives. Now, when you get to dynamic application security or binary static analysis, in my mind, those things can break builds. They take longer to run, but you run them in parallel to your unit tests, to your integration tests. And now you have the opportunity to say, okay, this is very likely a real problem. So we actually do have to break the build there. Now, Paul, I have a question for you as well, especially in your development process internally. Are you breaking builds or even considering breaking builds at the unit test level or at the integration test level? Because I have opinions on this, but I want to kind of hear what you're doing first.
Our build process is different in that we include a phase in user acceptance testing. that, to me, that will break a build, right? If the user's just like, this is just not, passing, certainly. I think a lot of the security testing, will break a build, and there's a certain threshold, that we're going to set on that. And those are all done at like different, stages of our development. And it's hard to talk about, the 5 or 6 different solutions when your like production process could be different as well, right?
Well, so that's the other thing that you want to try and avoid, right? Is continuous integration and continuous deployment, or continuous development, as some people will call it. So, for me, in my mind anyway, is you should always be running at least the binary static analysis and the dynamic application scanning solutions at unit test time. And the reason that I suggest that, or I even consider that, is because the things that you introduce for vulnerabilities at that level should certainly be swept away before you even get to the point of integration testing. So
yeah,
I'm starting to think about, okay, how fast can I break the build to get rapid feedback? The second principle of DevOps back to the development team. And quite frankly, your dynamic analysis tools are going to produce a lot faster feedback if you're doing it at unit test level, because your application's a lot smaller. Same with binary static analysis, right? You don't have a huge binary. You might have a small set of functions. Now, of course, you want to run those again when you get to integration testing, because now you're part of a much bigger application. And so there could be some crosstalk there that produces vulnerabilities. But
no,
at the end of the day,
yeah, I agree. I think you're more looking for security vulnerabilities as early in the process as you can.
Yeah.
I mean, in any other bug that you can get before it gets to integration or QA, right?
Exactly. Well, and also too, the open source stuff, right? You should be doing that before it even gets into version control, because that's the sort of thing that as soon as you go ahead and have to change a version of a library, you could be breaking all sorts of other functionality, as is going to be found in the unit testing, where suddenly your unit tests are good, but then if your libraries are broken, you go back and you change the library, your unit tests might now fail. So that's, in my mind, the sort of thing that you've got to do those, all of them, as early as possible. Unit testing, especially wherever you can, right? It doesn't always make sense depending on what you're building for, like a web app, for example. But if you can, you should, because at the end of the day, anything caught at that level is going to change all of the development downstream from integration testing standpoint. So yeah, it's a problem that if you address it early, you're in a good place. Now, I think, Paul, that once you've got kind of that fast flow and that rapid feedback, right, you're now testing in unit testing specifically, and then you're going ahead and now at the point where you're testing in, say, an integration phase or later, you get to the point where you need to have the continuous feedback, right, or the rapid feedback model and continuous learning. So runtime protection, as you kind of stated there earlier, comes in, I think, at this level, right? So now you have an opportunity to run a DAST tool by something. You're running the application, and maybe the RASP, as it would be called, is catching some of the things that maybe your dynamic analysis didn't actually catch, right? It ran the tests but didn't identify those as vulnerabilities. So in my mind, you should probably have a staging or a test environment that has RASP in place to just see, what's effectively being blocked, what was identified previously as a vulnerability that doesn't have RASP, and what is effectively being blocked, because now I can say, okay, that's maybe a high-level bug, but I know for a fact that my RASP is protecting me here. I don't necessarily need to break the build, but I can at least, project a timeline of fixing that to, say, a week or 2 weeks, as opposed to preventing anything from going to production for end of quarter sales or whatever, right? So it's trade-offs. It's a idea of business value and things of that nature. I don't know if you have thoughts around that, because WAF for the longest time has been a problem. So
it's interesting. I like your idea where you have a separate environment that you deploy to that has the protections in place, and maybe there's a class of bugs where you're like, well, yeah, these exist, but when we deployed to our RASP or web protected environment, it actually caught it, and so if the push is critical, we push it knowing that we have protection, but we go back and fix it in the next build. That's interesting. I'd never considered that type of model before. And I guess if you're, like you say, your application is really critical, like if you have to do a push for something other reason, it's nice to know that if there were a lower level or maybe some security vulnerability introduced, that you're protected. But you still got to fix it, though.
Yeah, well, and that's part of the problem, right? Like you need your runtime protection or your runtime application security protections to provide you a feedback mechanism that allows you to put forward those tickets into the next iteration or what have you, right? So it's kind of one of those things where you need at least 20% time to be addressing technical debt, and guess what? That's one way to identify technical debt that allows you to still push things out to to a production environment. I think, though, Paul, this all kind of falls into your stage 4, as you kind of commented on, right? So microservices and Docker containers. No matter if you're using Docker containers or you're using some sort of AMIs inside of Amazon or something in Azure, right? Your developers need to be able to rapidly test all of their unit tests, their integration tests in production-like environments, right? And that's production-like environments that have protections and production-like environments that don't, because the protections might interfere with your test suite, right? So it's a situation where, regardless of what you're doing, one of the things that you now have to do once you have visibility is identify bottlenecks. And a bottleneck in a lot of places is going to be getting an environment set up automatically where pushing to production is a non-event, right? Because you've already done all of your tests in production-like environments, and you've run all of your security solutions in those production-like environments, including your protections, to determine that, okay, yes, we can still push to production. We already have the protections in place for some of this. That is creating the tickets to make sure we fix them later. But in my mind, that's one of the biggest problems that a lot of teams don't actually hit on is, and it's actually quoted, I'm kind of paraphrasing, but it's quoted in the DevOps handbook that says the biggest indicator of ability to push to production safely and securely and be productive as a development team is not whether or not you're using version control, but it's whether or not your operations team is using version control to allow, one-click pushes to production. The operations side of actually getting part of the DevOps model down and using that rapid feedback model and using all of the infrastructure as code inside of the version control is going to make a big difference for your organization. And I think that a lot of companies today, that's probably the holdout, right? Is people don't want to necessarily be doing devy type or development type things if they're in ops. They didn't go to school to do dev, but now they kind of have to. So I don't know, Paul, what are your thoughts there, especially because you and I both have been very much into the Docker revolution, as I like to think of it. And I see a lot of value in it. And, I'm more of a dev, admittedly, but I think that a lot of ops folks could benefit from it.
Yeah, no, I definitely think there's huge benefits there, just in terms of operations, right? I want to go back to the point where, like, at what point do you start applying your protections? And if you don't apply protections in your development environments, your testing environments, your staging environments, what if those get hacked, right? Because the protections aren't there. And that's some of my concern is, I think a big determining factor is, what are you working with production data or are you working with test data, right? Because what we don't want is, like, especially in our integration testing, for testing with real data, that's more like a production system, that's going to need those protections to prevent against some kind of data leak if someone gets in. I think in your other development environments, access to source code could be intellectual property. That could be concerning as well. So be careful where you are not applying your protections, because that ends up being like your weakest link, and that's where you could likely get hacked. And that's but that's a balance too. Like Keith said, your protections could screw things up, and it doesn't really matter because it's going to benefit from those in production. But that's a balancing act. Well,
so I think that the way to test, right? So if you're going to do anything in a staging or a pre-production environment, it should be with fake data. Honestly, it has to be. And the reason is to exactly your point, Paul. Like, you are probably doing less on the protection side for those environments. I mean, granted, they're probably or should be all internal anyway. But even still, allowing developers access to production type data could cause all sorts of problems as a business from an insider threat, like threat modeling, right? So in my mind, if you're going to be testing, quote unquote, testing in production, you should actually follow, there's a formal name for it. And again, it's in the DevOps handbook, but effectively a shadow deployment is kind of the way to think of it, right? You push your functionality into production. It is called as like maybe a asynchronous call to that feature set so that you can test under load, right? So you can get actual production like loads to your new functionality. You get actual production like inputs to that set, and then any sort of errors that occur or any sort of feedback loops into the rest of your production environment are stubbed out. So effectively, it dies silently, but you can log it.
Here's what the issue that I have with our applications is: in production, you've got connections to third parties. Maybe they're APIs, maybe they're libraries or whatever. They're used in a specific way only in production, right? And like sometimes, depending on how you test, like you're never going to know that there's an issue until you push into production. And you're like, oh, the way that connection was built this way, like it's broken. But in your testing, you're creating these other fake connections that there's variables that you control that you made it work. Those same variables exist in production, but were slightly different for whatever reason, and now all of a sudden they don't work. And that's the problem that I run into when you've got interconnectivity, if you will, or external connectivity that is very specific to production that's difficult to replicate unless you replicate the whole thing.
So it sounds like, that's one option, right? And it sounds like part of your problem is this. You're not truly doing integration testing until you're kind of using similar or replications of the same environment, right? So a replicated connection out to, YouTube or Facebook or whatever, right? Like third-party integrators that you're using, right? So you, in some ways, you actually do need to do some sort of shadow testing of that, right? So it's in quote unquote production, but it has no true write functionality, or maybe it's attempting to make a write and then we'll go ahead and clean up after itself, right? So that's a delicate balance and a delicate process of building really good tests that can actually ensure that the connections are working appropriately, and then once you've confirmed that, have a kind of a silent back off, right?
Well, and I think that's particularly problematic with APIs because you have to go to Google or Facebook or whatever site and configure some type of connector, some type of authentication, and that's a configuration process. So I guess we all just have to get better at building and testing that, that kind of stuff.
The other side of it is your configurations should also live in version control, right? So the ops side of it is any change that is made to your production environment must be in version control. And so the way to actually control for this, as annoying as it probably will be for you, Paul, is you should basically for your AMIs that you push into a production environment should have no SSH login, no remote login capabilities of any kind. And effectively, you then want to start leveraging what's called a mutable infrastructure, right? Anything that is in production is as it is going to be in production, and any changes must first be made into version control and then respin up the production environment accordingly, right? Now, with that, you can also then follow the blue-yellow pattern of deployment, as it's called, which is you have your yellow, I think it's actually blue environment that is in fact truly production. And then you have your yellow environment that you spin up that is now effectively your pre-production staging environment. And what you do is you just kind of, at the web server level, you point the application that you're now using to this new yellow environment, and that becomes blue. And then the old one becomes yellow. So now you have a fallback mechanism, right? So if something goes wrong, you can just simply switch back to the previous environment.
If you merge both those environments, is it a green environment? Never mind.
Honestly, it depends on if you're using paints or lights. So if we get into the whole concepts of color and the eye, we're not going to go there. But
no, that's exactly right. I think your approach is solid for that.
It's all in the DevOps handbook, man. Literally, at some point, I'm going to be what I should do is I should actually do like a blog post with all of my little tabs that I've put in here where it's blue. Here, I'll put it closer to the camera. Blue is like business value. Red is like don't do those things. And yellow is like technical things that you can actually do to enable this process, right? So some of that comes into different patterns that you can use. So you could also do the other thing, Paul, is like feature toggles, right? So you don't want to roll back the release, but if you can just simply toggle that feature off that broke the way that production's supposed to be working while you go and fix it, now you have an opportunity where you don't have to necessarily roll back your environment, but you can simply roll forward, which is, turn the feature toggle off, continue to have your production environment the way it's supposed to be working.
Right. Or just not rely,
a
lot of features we're building in now, like we're just not relying on them. Like, so we can still use the application the way we always did, right? But we're building in these new functionality. It's not part of the production workflow. That's still going fine, but we're keeping it separate so we can test and define these things in production, have that information there, test features, have it live in production, make sure it's not breaking anything. And then slowly that starts, maybe the next release, we'll integrate one of those new features into the process, right? And keep it separate, like you said, so you can toggle it. And that can be difficult depending on your application. In our case, some of our new features are about collecting data. So I'm like, push them in production. Like, if we're not using that data in the main value stream in the application, that's fine. Let's test how it collects that data and debug it and let users have at it, even in production.
And it sounds like you're doing two things right with that, which is, one, it's loosely coupled, right? There's no real coupling between the two sets of functionality or features, and so therefore you can have both of them live in production simultaneously. The other thing that it sounds like you're doing is what's called the strangler pattern, which is kind of like the strangler vines, right? You're effectively putting all of your old stuff behind like an API, right? And so you can still call it and query it as you need to, but then you can build new features that ultimately will replace the old API until eventually you can just phase it all out. But you have to do that slowly, because if you're coming from a monolith structure and you're moving away from that, you can't just do it wholesale, because you're likely to break a lot of things.
Yeah.
So,
and one of the things we're doing now, I mean, I'll disclose some of what we're working on publicly, right, is our software allows us to publish all of our shows. And what we quickly realized, after studying the DevOps handbook and all that stuff, and also the Phoenix project, was there's a lot of information about a show that has to be carried forward, right? So we started like whiteboarding this. I was like, wow, like, okay, now let's talk about which information we want to put into our system and track moving forward, right? So there's obviously a lot of information about a show that we've defined and started building into our system. Like, okay, who are the hosts? Who are the sponsors? What announcements did we have? What information about the host do we want to collect and have that follow that throughout the whole system? So we're starting to build that stuff in. Now, it's not necessarily being used in the way we use the software today, but we're testing that functionality. Let's go define all the announcements, define all the hosts. Like, what does that look like? And doing those level of tests and getting the user feedback as well.
Yeah, and that's ultimately, that's the DevOps process in a nutshell, is feedback models that allow you to then go and make changes, right? And so I think the last thing, by the way, kind of circling back on the security side of things, was training. Ultimately, like, that is one of those things that you can actually, short circuit this entire process if you have really good training. We had Matthias Madhu on the show early. He was our first interviewed guest that offers training as well. So people can go back and watch that episode as well. But yeah, there is something to be said for good developer training that actually gets them involved. And there's a lot of bad developer training out there. I will tell you that right now. I'm not going to name vendors, not going to, shame anybody or call anybody out as doing it really well. But that is one of those things that if you get really engaged developers and you can turn them into security champions, which even makes your life easier down the line as well when they think of threat modeling, right? That's a kind of pre-writing code. There's a lot to be said for good training in the development security space. And honestly, you got to put your hands on the keyboard and try it out yourself before you go and buy it, because some of it out there is just garbage. I'm just going to leave it at that. So
I agree.
So with that, I think we've had a good discussion on this. We're going to take a short break and then come back with the news.